The automobile, as well as its internal combustion engine, has been the most profound advancement in the transportation industry to this day. Over the past decade, scientific research has been aimed to increase the power and improve efficiency banks of these engines. Power is generated through the controlled combustion of fuel and air. One of the most simple and most straightforward methods to increase the amount of air and fuel pumped by the engine is to increase the number of available cylinders or the displacement size of these cylinders. These changes do increase the power generated, but also increase the combustion capacity of the engine, increasing the volume of noxious gases discharged by the exhaust system. Therefore, the increase in power would lead to a decrease in the efficiency bank, harming the environment even more. Researching solutions to increase the power without harming efficiency was the turbocharger. A turbocharger essentially uses a forced induction mechanism to rapidly increase the volume of air in the combustion chambers of the engine, increasing combustion capacity without making the engine burn more fuel. A turbocharger is basically a high-powered air pump consisting of three main components: a turbine which collects air to spin, a compressor which then sends the air to be collected by an intercooler. In a standard aspirated piston engine, the air from the engine's intake system is pushed into the combustion chambers by atmospheric pressure. The ratio of the amount of air received through the intake system compared to the theoretical amount of air in the combustion chamber could be called the volumetric efficiency ratio. A turbocharger's main objective is to maximize an engine's volumetric efficiency ratio by increasing the density of the air going into the combustion chambers, allowing more power in the engine per piston stroke. A standard turbocharger has two main rotating parts. Installed in the same metal shaft, these parts both rotate together. One of them, as mentioned previously, is called a turbine. It is directly connected to the vehicle's exhaust system and sits in a gas stream from the cylinders. As fuel and air are burnt in the combustion chambers, hot air from the cylinders is blown past the turbine blades, causing them to rotate, as well as the entire central rotating assembly. The second part of the central rotating assembly is called the compressor. It is mounted inside or close to the vehicle's intake system. As it rotates, it draws air from the intake system and forces the air into the cylinder combustion chambers to increase combustion. There is a fallback to this system. As air is rapidly compressed and pressurized by these components, it increases the practical kinetic energy and overall temperature. Hot air, which is much less dense than cold air, supports combustion a bit less than cold air. So to increase the efficiency of the hot air, the hot air is passed through a heat exchanger to cool it down. The most commonly used type of heat exchanger on turbocharged engines is the intercooler. The intercooler cools down the air compressed. As the temperature climbs and the density reduces, so does the oxygen content in the air. By cooling down the air, the intercooler allows denser, more oxygen-rich air into the engine's combustion chambers, allowing more fuel to be burnt per piston stroke, thus improving the overall generated power by the engine. The intercooler also keeps the air going to the engine cylinders at a fairly constant temperature, which improves reliability and allows the air and fuel to mix at a safe, consistent ratio. To recap, a turbocharger's simple mode of operation: air from an intake system flows down the compressor. The compressor squeezes the air and passes it through the intercooler, which reduces the temperature. The cooled compressed air enters the engine through the cylinder intake. Extra oxygen helps the fuel to burn at a faster rate. The increase in combustion causes an increase in power sent to the wheels from the piston, drive shafts, and gears. Wasted gas from the exhaust system blows past the turbine fan and makes it rotate at high speed. Since the turbine and compressor are connected to the same drive shafts, the turbine spins, so does the compressor. Turbochargers are known to provide a typical boost of 6 to 8 pounds per square inch. Since the atmospheric pressure is approximately 14.7 psi, therefore turbochargers provide an estimated 30 to 40% power improvement due to imperfect efficiency and power loss due to heat.